Good morning, students, and welcome to my class, Business 230. I'll be your substitute teacher today as Ocean has called in sick, unfortunately. My name is Samantha Parker. You will refer to me as Miss Parker. And today in class, we're going to learn all about confidence intervals and how to get the population proportion P. So let's get right to it. Alright guys, that is so much better. I would just like to inform everyone today that Ocean has let me know that if anyone acts up today, she will chopstick you. So watch out. But for today, we're going to be putting the chopsticks away. So we're going to create a confidence interval for a single population proportion for P, okay? That's what we're doing. In one of these questions, you'll be asked to determine the confidence interval for a population proportion P. At a particular confidence level, we will be given a sample size called N. Let me show you. Ding. Just like this one that I'm not holding up. We will either be given the sample proportion P hat. Can you see my hat? All right, so, or we will be given enough information to calculate P hat. Now that's probably what we're going to be doing because I'd like to show you all this thing, because if you don't know it, you're not going to pass. Pronto? Cool. For these types of problems, we will always use the standard normal deviation, as I like to call it, SND. Yeah, SND, not STD. No, guys, do not get STDs. But SND to find the critical value of Z, called Z alpha over 2. So we take the given confidence level and divide it by 2 and convert it into a decimal. Are you keeping up with me? So it's gonna look something like this. Zoom, zoom, zoom. So we're taking the confidence percentage or given level and dividing it by 2. All right guys, so I'm just gonna give you all a little introductory or just a refresher to help you guys remember how to look up that Z value. So how to look up Z. All right, so we're gonna take that confidence interval percentage, 95%, and we're dividing it by 2, point blank. And that's gonna equal a number that I can't do in my head and need a calculator for. So we're gonna get the 45 or 47.5%. And we're gonna actually move it over 2 decimal places that way. So we're gonna make it to 0. My pen is running out. 0.5. 0475, not 0.5. Okay? So when we do that, we're gonna take our Z table, and remember it's like this. Wow. Let's pause for a second. I need a new pen. All right, we're using red, guys. Apologies. All right, now that's a color. Hope you all can see that. So it's gonna kind of be like a multiplication chart, where in grade school where we went down and go to the side or whatever. But for this one, we're actually gonna find this number within, okay? We're gonna find this number. So we found it. Ooh, there she is. There she is, okay? So we're gonna actually go this way, and we're gonna go up. So we're gonna look, And we're gonna look. And so we can put these two together, 96, and that's the Z value. And in order to get the confidence interval, we'll be using this formula, AP hat, which I'll also be going over of how to get that letter when we get to the question. So this will be the full-on formula. So we'll be using the sample behind me to demonstrate how all this works and how we put it together. All right? So it says, oh, hold up. Let me get my pointer. All right. In a survey of 200 randomly selected Canadians, it is found that 176 of them know how to swim. Find the 95% confidence interval for P, the population proportion of Canadians who know how to swim. All right, so the 95% confidence interval is basically like the width of the interval. So we have N, but let's just write down all the letters we do have. We have N, we have 200, N equaling the sample size. Capiche? All right, we're also gonna show, so we have N 200, okay? We have X, which is going to equal to 160, because those are the amount of yeses that can swim, okay? Now we're gonna find P hat. And that's when we do, it's gonna be X over N, which equals 176 over 200, which is gonna equal to 0.88. I just had to double check to make sure that that's what it was. And this is going to be our example proportion. Double checking my work, as you all should during exams. What did I say? Example proportion. Proportion. All right, spelling is not my strong suit. All right, so once we have these, we're gonna move on to find Z. So we're gonna draw a hill. All right, we're gonna put 0 here. We're gonna do Z. All right. Okay, we're gonna take the 95%, 95, we're gonna divide it by 2, which we did last time, which technically gives us this, but we're gonna move it over, okay? We're gonna move it over to the 100th place, okay? So we got 47, 5. Now that's the number we're gonna use to look up on the Z, to look up on our sheet. Beautiful, don't you think? So, all right, we can kind of see it here, perfect. We're gonna go and look for 0.475. All right, that's gonna bring us all the way to this guy right here. So we've highlighted him. And we're gonna go up and across. But let's do across first so that we can get that number. So that number is going to be 1.9. All right, whoopsies. And we're gonna go up to 0.06. All right, y'all remember that? So the Z value is going to be Wow, that is not a very good S. It's going to be 1.96. So I'm just gonna do that. And we're gonna do that. That way we remember. I pointed exactly at it. I'm pretty proud of myself right there. All right, now that we have our critical Z value of 1.96, we can actually move on to this. So that's going to be our equation. So we're going to do it one step at a time, because I find if I do it this way as opposed to just doing it all at once, there's less likely for error. This is one of the most important parts of the equation, because you need this one. You need this bad boy. Let's move over here. All right. We're gonna do the lower. I like to do this. LCL, the lower confidence level. All right. Now how we do this one, pretty simple. We're gonna minus that 0.405, okay? Which is gonna equal 0.835. Voila. Now, I don't know why I put lower above, because it would make more sense if lower was below, right? Why did I do that? Anyway, switch them up when you do your notes. Wow. Okay, so this is going to be the upper confidence level. So we're going to do the upper CL. And that's pretty simple. Well, honestly, I think this is kind of fun because it's kind of easier. 0.050, which is going to equal, I don't know why I didn't just do that on the other side, 0.9250. Isn't that beautiful? All right. So, in conclusion, let's back up. So, in conclusion, we're going to have the lower CL and the upper CL. So when you get this final number, and you get that Z, which you'll need for sure, okay? We all know how to do the Z now. We all know how to look on it, okay? And as long as we have that N, we're golden. And we use this equation, and at the very end, once you get there, it's easy peasy lemon squeezy. We do the minus for the lower, okay? And we do the positive for the upper. Negative, minus, whatever you want to call it. Think of it as, you know, so we're gonna have lower, upper, and if a question comes up and asks you for the lower confidence interval, there you go. And let's say the next question comes up and asks you for the upper. There you go. All right, guys, so that concludes my presentation of creating a confidence interval level for a single proportion population P. Thank you all for coming to class, and hopefully Ocean will feel better by the end of next week and she'll be back. I will be seeing you around the school. It was a slice. Have fun. Goodbye.